want to put them in order. That's always step one. So I guess I can write that over here. Step one, put in order. Step one, put in order. All right, now we are going to talk about all the different measures of tendencies and things that we can do. First, I want to introduce the min and max. And that's just quite simply the highest and lowest number. Minimum is 1, maximum is 9. That's another reason we put them in order. It's really easy to see the minimum number 1 and maximum number 9. Next, I want to talk about the measures of central tendency. That's your mean, your median, and your mode. And like I said, largely this should feel like review because most of it is. And so to find the mean, you're just going to take the average. So you're going to add all of these numbers up and divide by the total numbers that there are. So I would do 1 plus 2 plus 3 plus 3 plus 4 plus 5 plus 5 plus 9. That's 32, and there are 1, 2, 3, 4, 5, 6, 7, 8 numbers. 32 divided by 8 is 4. So my mean is 4. Median is the middle number, and so I'm just going to cross these out until I'm left at the middle number. If there's no true middle number, you've got to think, what is exactly between 3 and 4? Well, 3.5. There is also a mathematical way to do this. You can take the average, or the mean, of 3 and 4. So 3 plus 4 is 7, and 7 divided by 2 is 3.5. So our median is 3.5. That's the middle of our data. Mode is the number that occurs most often. And if you look, 3 occurs twice, and 5 occurs twice. So this is bimodal. There are 2 modes, 3 and 5. If you have any more than 2 modes, chances are they aren't significant enough. And if no number occurs more than once, then you would just say no mode. It's important to know that these 3 are called measures of central tendency. It tends to tell us how the center of our data looks. So we'll put central tendency right there. Maybe I need to move it a little bit more. So those 3 are your central tendencies. After mean, median, mode, minimum, maximum, you want to find the range. And that is just the maximum minus the minimum. So 9 minus 1 is 8. Our range is 8. So hopefully all of that was pretty much review. The next things I want to talk about are more moving into a box and whisker plot. And so this way we can find quartiles and interquartile ranges and such. So I'm going to erase these markings up here. So talking about a box and whisker plot, we want to know Q1, that's quartile 1, Q2, that's quartile 2, and Q3. Now, Q2 is the easiest. It's just the median, which is 3.5. That's our Q2. To find Q1 and Q3, you look at all the numbers left. So if my median is right here, that's my Q2 at 3.5. All the numbers left represent my quartile 1. All the numbers to the right represent my quartile 3. And so I need to find the median of those parts. And so if I find the median here, 2 plus 3 is 5, and 5 divided by 2 is 2.5. So my Q1 value is 2.5. And over here in the red, there is no number between 5 and 5, and if you did it the math way, 5 plus 5 is 10, and 10 divided by 2 is 5. So my Q3 is 5. And so interquartile range is just going to be Q3 minus Q1, which is 5 minus 2.5. which is 2.5. So my interquartile range is also 2.5. And so how do we use this? Well, we use all of this information here, these quartiles and such, to draw a box and whisker plot. So to draw a box and whisker plot, you need a number line, and you are going to plot certain points on this number line. You're going to plot your minimum, your maximum, your Q1, your Q2, your Q3. So very easy. I always start with my Q1 and 2. So Q1 is at 2.5, so I'm going to go, I got 2 here, we got 3, 4, 5, 6, 7, 8, 9, 10. So my number line is really from 0 to 10. So I'm going to draw a line at Q1 at 2.5. I'm going to draw a line at Q2, 3.5. And I'm going to draw a line at Q3, which is at 5. That composes the box of my box and whisker. Q1, Q2, Q3. And then I will a point at my minimum, which is at 1, and my maximum, which is at 9. And I connect those with a line to make my whiskers. And so you can see, by box and whisker plot, you can see how the central part of the data interacts, what the minimum and maximum look like. This looks like it could be an outlier. We'll talk more about that a little bit later. So you need to know how to make a box and whisker plot. The other thing about a box and whisker plot is that it divides it into quarters. There's quarter 1. That's going to be confusing. Basically, everything here is quarter 1. Everything in there is quarter 2. Everything in there is quarter 3. And then everything there is quarter 4. It divides our data into 4 quarters. And so you can be asked questions, how, if you're looking at 50% of the data, you're looking at this half, or 75, quarters 1 through 3, or the last quarter, you're just looking at quarter 4. So it could ask you some questions about that information. Just know that that's why we have 3 quartiles, 1, 2, and 3, so it can divide it into 4 quarters. All right, moving on, I want to talk a little bit about standard deviation and outliers. And so, and then I'm going to show you how to do it all in a calculator. So a standard deviation is going to be represented by a sigma. And the formula looks kind of nasty. It's sigma x minus x with a little bar over it, and these are parentheses, not absolute value signs, squared over n. And so I'm not going to make you do it by hand. You'll be able to do this by calculator, but I want to kind of show you how to do it by hand. That way maybe you appreciate what the calculator does. So to find the standard deviation, essentially what's happening is we are finding the difference between our values. So these are our values. Let me do that in a different color. Blue. These are our values here. These are our x values. We want to find the difference between our x values and the mean. The mean is your x with a little bar over it. So I'm just going to take, and this stands for the sum. So I'm going to take my value minus my mean, value minus my mean, value minus my mean for all of my values, and add that together, square it, or I'm going to do value minus the mean squared, add all those results together, and divide it by the total number of results. So 1, 2, 3, 4, 5, 6, 7, 8. N equals 8. There are 8 terms in my set of data. So let's just kind of look what that looks like. 1 minus 4, so my first value minus my average is 3. And 3 squared is 9. So I got to do that for all of this data. So I'm just going to copy this. We need to do this a total of 8 times. Make it look a little smaller so we can fit it all on here. And so if I change that to 2, 2 minus 4 is negative 2. Negative 2 squared is 4. 3 minus 4 is negative 1, and negative 1 squared is 1. 4 minus 4 is 0, and 0 squared is 0. We got to keep going. Oop, there's another 3 in there. Five minus 4 is 1. 1 squared is 1. We have another one of those because there's 2 5s. And then we have a 9. So let me squeeze that last one in there. 9 minus 4 is 5, and 5 squared is 25. So now, this is like the parenthesis part. That's what I've done here. I've taken all of my values and subtracted my mean from them and squared it. So now I need to add those all together, divide by 8, and take the square root of it. So if I do that real quick, I've got 9 plus 4 plus 1 plus 1 plus 0 plus 1 plus 1 plus 25. That's 42. 42 divided by 8 is 5.25, and the square root of 5.25 is 2.29. So my standard deviation of this data set is 2.29. And so why do we use the standard deviation? Well, that kind of tells us how spread out our data is, how, on average, how far away our values deviate from the mean. And we'll talk about this. This will make a lot more sense when we do normal distribution. If there's one standard deviation, that means one standard deviation below 4 or above 4. That's all within, those values are within one standard deviation. And so for this chapter, or for this moment in time, why we're learning standard deviation is because that's how we can determine if something is an outlier. For something to be an outlier, it has to be 3 standard deviations away. So either 3 standard deviations above or 3 standard deviations below. So if I take 2.29, which was my standard deviation there, and I multiply it by 3, 6.87. So anything that is 6.87 higher than 4 would be considered an outlier, and anything 6.87 below 4 would be considered an outlier. And so you can see originally somebody might have thought that 9 was an outlier, but 4 plus 6.87 is 10.87. So 9 actually fits the data. It looks like it possibly could be an outlier, but it's within 3 standard deviations of our mean. So that's what we are going to use standard deviation for in this chapter. All right, so real quick, I want to show you how you can do all of this on a calculator. So you need to be able to do everything except for standard deviation without a calculator, but if you have a calculator, it makes it nice. Go to Stat, you're going to edit a list, and you're going to put your numbers in there. The reason that this is awesome is because they don't have to be in order. So if we give you a list that's not in order, doing it in your calculator, it doesn't matter. Once you have your list, go back to Stat, go over to Calculate, and you want to do one variable stats. So if you hit Enter, you want to make sure your list is in there. We'll talk a little bit about frequency tables, but for now, don't worry about it. So we'll just leave our frequency list blank, and then you hit Calculate. And we'll find out how good my math was here in a minute. So the mean, x with the little bar over is 4. That's what we got. It tells us our standard deviation, 2.29. That's what we got. Tells our number of terms is 8. Our minimum is 1. Q1 is 2.5. Our median is 3.5. Our Q3 is 5. Our max is 9.